It's my great pleasure to introduce today's first keynote, Professor Barbara Planck. We have met, we talked a couple minutes earlier, in another life, before COVID. It was within the cost action, the action European Union grant for networking. So in this way, me and Barbara and Martin in the same network. The name of this cost action was absolutely fantastic. I like it right now. It was 2019. Multi-thread generation, multitask, multilingual, multimodal language generation in 2019. It was very interesting. Okay, so I will not repeat what you can read on the web site of our conference. I just would like to mention that research of Barbara focuses on what she calls human-facing NLP. Am I right? Yes. Yeah. Okay. Just to make our models more capable, more flexible, more inclusive for human. And okay. Barbara, floor is yours.
All right. Okay, so first of all, thanks a lot for Marcin and Maria for inviting me here, or the whole organization team. And I apologize, my voice is still a little bit not completely back, but I will try to do my best here today. All right, so I try to give you a view about human-centered LLMs for inclusive language technologies today from the perspective of an NLP researcher that has been in the field. Okay. All right, so, okay, we are back. So, from a perspective of an NLP person, and if you think about NLP today, we might be thinking about essentially LLMs, right? LLMs that are really everywhere. And as we heard before, we met in a pre-corona time, but also in a time where LLMs were not yet there. LLMs existed, but they were not so omnipresent as they are today. In fact, as what happened is they were like this bulldozer that arrived and has entered our field, and it was really a disruptive moment because this technology came very, very suddenly, or it felt suddenly. And it has also, in the way, interrupted our own field, but also increased outreach of NLP tremendously. And if I look now and show you what happened in NLP is that if you look just at the main conference at ACL and at the number of papers in the title that mention LLMs or similar terms, we saw already that in 2024, almost half of the papers were about LLMs. And this is clearly underestimating the number, right? It's just a simple keyword search in the titles. And this is really skyrocketed. So it's really a disruptive, but also a very interesting moment to be in this field right now, where we work with language and try to teach computers to understand all these facets and nuances of language. And if we think about language, let me actually have a look at how many of you are working with NLP technology here. Hands up. How many of you? Yeah, yes, yep, okay, a good proportion. That's nice. So if you think about language models, they have entered our field, and you can see here the evolution of language models that appear in a very, very fast pace. Okay, so they have really there's new language models out there all the time, different kinds, and decoder-only models have really taken up, and that's where we are, ChatGPT at this moment when all of this has been released to the public was very influential moment. But if we compare language models for a moment to language or languages, let's have a look at Indo-Germanic branch, and here you see And I just want to point out here that language itself is also evolving and changing, right? And the key message here is look at the time scale, right? Language models are really months to weeks to develop new language models, but languages take thousands of years to develop in this way they developed overall. Okay, so it's really fascinating times. But if you think about LLMs today, right? How many of you use LLMs on a regular basis? Really? Not more? All right. That they are like maybe a little bit of a Swiss knife for NLP or for AI or for sciences or society broadly, right? And here is, or I want to put these questions, are they really a Swiss knife that we can use for all sorts of things? And here's an image that I asked DALL-E to generate, given this prompt, and turned out to be quite fascinating and nice picture, right? But if you look at the details, maybe do you notice some things are not exactly right? So maybe it's telling us something already. All right, so I want to show you in this talk also a little bit of where are things that don't work so well yet with language models or language technologies. And one of the things that is very natural for language is it's characterized by variability, right? Variability meaning, for instance, an example of just a single word like nothing that can be spelled in this way, but could be spelled in so many different ways. And the key is that in language, it's not just noise or mistakes, but it's also a way to express yourself with different forms, with different expressions. And so this choice of how you write, for instance, is also carrying social meaning. And if you think about all this richness of language today, this is not captured in today's model. So if we are trying to model this, it's only able to model a small subset of this variability, of this richness of language out there. And indeed, if you think about today's big language models, they are still focused on standard languages, right? And they are not working well on data that has, which is not following the standard and thus gives you high error rates and is not very inclusive, okay? So that's also one angle I want to highlight today. How can we make language technologies which are more inclusive now in the sense of including diversity of languages, language varieties? And so let me give you an example. If we look just at Europe and languages in Europe, and let's zoom into one language, right? Like German. So here, German, right? Roughly speaking. What we do think of it in NLP terms is typically one language, right? One monolith that we are trying to model. But in reality, it's much more complex. So if we look, let's zoom in a little bit more into Bavarian, roughly spoken here, right? And how many of you speak Bavarian, by the way? Not so many, right? Yes, I can imagine. But if we look into how many of you knew that there is so much richness even inside Bavarian varieties, right? And this is something that's really not captured well today if you think of this richness of variation. And so this is actually a big opportunity also for us to think about how can we embrace this within language variation, even in multilingual NLP or multilingual language models. All right, so we'll get into this a little bit later in my talk, but let me first start off with giving you an outline of the rest of the talk. I will start off with going into challenges and trust issues, because now we have this fantastic moment of these great models, but there are also issues that come with these, and so what are some things to pay attention to? And then in the second part, I will try to talk about embracing variation more holistically, and I will flesh out what I mean there before I conclude towards more trustworthy human-centered NLP. All right, so let's go into trust issues, because now with LLMs, a lot of new questions emerge, and how do we essentially interact with this new generative technology. For instance, if you think about model behavior, does it matter how we prompt an LLM, right? Does it give an impact? And there is an increasing amount of research showing that the way you prompt, you type your prompt, has really a big impact on the outcome that you're getting. And I'm highlighting here one of the studies, just to give you an idea. Why do I highlight this one? Because they took a linguistic angle, modifying the prompts in small, what's called minimal pairs, so that you have full control of what you're changing, right? What happens if you change from active to passive voice, or you change the mood or the modality and so on? And they show in this paper that it's very sensitive to these small changes, which for us often don't matter, right? But your output, or in particular, if you're interested in the performance of some task, then the performance is very, very sensitive to these linguistic variations. Another thing that has been increasingly done nowadays is to use LLMs as a sort of knowledge structure, knowledge source, or opinion source, right? And a very common thing that's done today is to ask multiple choice question answers. Do question answering. And so here, for instance, you have this question about, one of who the web was affected by in which year, and asking multiple choice options. And now we have to deal with this generative model. So how do we actually extract the answer from these language models? And what's very commonly done is to actually look for the logits of the first token predicted afterwards. So essentially look here on not the text that's outputted, but just at the probability of the answer keys for your question. And this now gives you, for instance, the option C, right? And this has become immensely popular because it's very easy to query the language model about its answer. So it's making LLM evaluation very easy, and it's very, very widely used. Now, is there any issue with that? Right? In fact, the question is, do answer options impact LLM outputs? And there is a very nice study here, for instance, but that shows how to map A and B to yes and no, right? And what you see is that essentially it doesn't really matter, right? It actually outputs a lot of the cases A. And this is known to be the A bias of language models. So it's very, it's over predicting A, and then might not make sense what you're getting out of it. And this is an effect that you might wonder, how frequent is this? And here you see different language models of different sizes, so from small to big. And you do see that this A bias is particularly prominent for smaller language models. It gets better with larger language models, so the A bias is reducing. But still, if you compare then to the entropy of the answer distributions that you would expect from a human to give, then you see that's very diverse, right? Humans give much more diverse answers, and language models are not reaching that. So this means we need to be really careful in interacting with these technologies in order to know how we extract the answers. In fact, with my PhD student, Shimpong, we were interested in, okay, well, a lot of people are using this logic-based approach. How does it actually compare to just looking at the answer, right? And so we did this study, and what we found is they do not match often. Okay, so indeed, if you do take these two ways of extracting answers, the token probability versus text answer, what I show you here is you might get a very different performance estimate out of it. But maybe more importantly is even the striking difference between them, right? It's a really huge difference. So we need to be careful about how we do this. Now you might say, okay, but we do just prompt the language model and, directly it's called. We don't let it reason about its answer, right? And in fact, there has been increasing amount of work that shows, okay, how can we get better language model outputs? And chain of thought is, for instance, one of these technologies, or nowadays reasoning models. And chain of thought, are they better and more sound? Actually, we were wondering. With my PhD student Philip, who's working on reasoning, we created this benchmark. Maybe interesting for some of you. It's a logic-based deductive inference benchmark with marbles and so on. And we were interested in actually comparing how do humans do on this versus language models do on this task. First of all, that was the background. But what we did is essentially ask the language model to also output the reasoning chain before concluding giving us the answer. And then we went and analyzed this reasoning chain in order to see how consistent is this actually with the answer and how sound is this reasoning. And what we found is, first of all, this deductive reasoning task, this was now a year ago. By now, these scores are probably a bit higher, but still, this deductive reasoning task is a very challenging task for language models. Even if you permute the answer option and take care of all these biases that I've shown you before. But what is really striking is that the reasoning chains that we got were really not of good quality. They were not sound, so there was a lot of issues in there. So we can't rely yet on this outputs. Okay, but let me show you now a little bit of another direction. We talked about multi-tree generation, so let's bring some images in as well. Here is a task where the idea is you get an image and you need to do visual question answering. And what do you say if I ask you now, what color is the bus? What would you say? Yes, exactly, right? Which bus? A very natural human way to answer. Indeed, so I shouldn't show you, but sorry, I was showing you already the answer. This is a purposely ambiguous question, right? Because the referent is underspecified. And so you might ask, yeah, but which bus are you talking about? Or you might describe the full picture. Or you might say the bus in the middle is blue, right? You pick a referent. Or you say the bus is blue, in a way underspecified, you're essentially ignoring that there is ambiguity in this picture or in this question. And so we were interested in this type of answers and coding them by, okay, green are the more natural ones, so you acknowledge that there is ambiguity, versus orange, you kind of pick a preferred object, versus red, you ignore that there are possible alternative objects. And so we were interested in, again, how do humans do on this task versus language models. And my answer here spoiled it already a little bit. LLMs are actually very overconfident in light of this ambiguity. What do I mean? If you look now at this plot here, is the more red, the more they ignore the ambiguity compared to humans, which are giving a lot of more the green answers, right? And this is an effect that you see throughout models, from open to closed models. So all of these models, all of them have it to some degree. But it's really striking how big these proportions here are, right? They wouldn't, even if we query them to say, look, if you have multiple possibilities, what would you say? Like hinting at that there is ambiguity, they would be overly confident in answering. So this means a lot to be done, right? This is actually very exciting because these language models are not yet that good as we think they are. So for us, it's very good news. But there was also this time, a few years back actually, where a lot of people went actually to GDPs, right, for answer extractions. And there was a discussion in our field, well, why should we even care about other models which are open weight if the closed source OpenAI solutions, for instance, at that time, are supposed to be the best ones? It was a long discussion. In fact, we met at a kind of Tagstuhl event, but and we discussed this intensely. And there are people who are really, we need to measure this, because there are of course opponents for using always the best out there versus putting science and reproducibility up and working with open source, open weight models. And so what we did is we essentially took a lot of tasks where we could get human judgments and compare a range of LLMs types on a wide variety of tasks. And I'm just showing you one result here. And the key is don't try to interpret exactly the picture. The key message here is there is no one winner, right? In this plot. So there is not always said that GDP would be the best model for some aspect that you might be interested in. And so LLMs are, if you think about trying to replace them with human judges for your, it scales up annotation. It's actually much cheaper to do annotation nowadays because we could potentially replace humans. No, hold on, right? You might actually not only get not the best model for your task, but you might also impact and get other biases that you don't know how to get into, get all other biases into the loop. So I think, nevertheless, this is a very interesting aspect. How can we do better human AI collaboration in order to scale up annotation and stuff? That's very interesting, but completely replacing human judgment, I would be very careful with that. Okay, so nevertheless, there is time to reflect, and I think there is really time of optimism as well, right? I've showed you now a lot of examples where we need to be careful and things don't work so nicely yet, but there is really also time to think about it, and time to think about how can we actually regain trust, because there is a lot to be done and a lot of power in these models. But if we think about regaining trust, then is that so simple? How can we do that? Okay, and in fact, if you think about language, there is variation. Back to my very example in the beginning, for instance, there's a lot of richness of nuances on how we can express our message, feelings, whatever, in language, and that gives rise to variation. We can express it in many ways, and variation in turn gives rise to uncertainty, right? It's actually, you can think of it as a process of modeling the data, right? And an uncertain process, and at the same time, also language models in themselves, if we think about them, they don't always know when they don't know. Okay, like this example of being overconfident is an example of where uncertainty estimation is not going yet that well. And so that's another angle that's very promising to look at in future. And why? Because it can help us understand when models might be going wrong. It might help us also to identify maybe when multiple views can hold, not just one view, or it can also, gain us trust when we know that the model is not sure, could abstain, could give us multiple answers. And in fact, if you think about trust, I found this very nice quote by David Hayes, who was one of the pioneers in our field, who had this quote on ACL 79, defining trust as arising from this knowledge of origin as well as knowledge of functional capacity. I think that's a very nice quote that's also mappable to our LLM world today. If we get more knowledge about the functional capacity of these models, as well as the origins of how are they developed, what went into them, what design decisions, what data, all of this whole process is getting more known, then we have more knowledge that helps us understand and anticipate what works and what doesn't work. Okay? All right. So with that, let me go into the next two bits where I will try to argue for embracing variation holistically in order to get more trustworthy solutions in future. Now, if we think about in AI broadly, right, we think about this pipeline often. We have data, we have models, we have evaluation. But if you think about variation, that actually impacts all of these three stages, right? Because there are moments where variation gives rise again to uncertainty in all of these three aspects, in the data, in the modeling, and evaluation. But luckily, there is also this kind of shift in the field where instead of here, we are focusing a lot on how to build architectures and, to get the model details right. There's an increasing importance of the data, thinking about what goes into the model, what should go into the model, and evaluation. How can we trustworthy evaluate these language models? And indeed, I want to show that indeed variation is again key in this pipeline, because variation impacts at one side the input space, right? There is language that we try to model. It's very, very rich. But if you think about non-standard languages, for example, or dialects, then this variability is not well recognized yet. Or if you think about the output space, right? We typically only model standards, or standardized categories are accepted. Okay, and overall, these two aspects taken together is what I consider variation. Variation in input, variation in output, but also variation in the research ecosystem, because I think it's going to be important, or it is important and increasingly happening, that communities look at each other and communicate more, to work together, to solve these issues together in order to holistically get more trustworthy AI in future. Okay? So this is the three views of variation that I consider. Okay, let me then zoom in into these actually two input variation, and show you just an example of two sentences, right? So here are two sentences about raining. It's actually quite fitting the weather here. It's expressing raining in English and in German, and it's kind of similar ways to express the same meaning, right? And if you think of this as kind of a dot, so this meaning as a dot in a space, right? We would have two sentences in German and in Italian and in English. And now we can think about data sets that are like about weather reports, right? So there is this space of weather reports. But if you think about the richness of language, we can have these in so many different languages. And so we can have a lot more than just weather reports. We have all sorts of data sets out there. And in fact, we have over 7,000 languages from this conceptual language space that we could sample from. Okay, so that's one dimension. And that's not the only dimension of variation. So we could, again, go further and think about subsets in this space according to other dimensions. And so we increasingly get a more complex language space that's driven by, for instance, like genre as another dimension. Or you can think about other dimensions that might influence and shape this space. And this is something I like to call variation space, because there are so many dimensions of variations that go into language, and we only always have a subset available when we try to model language. Okay, but I think this is a nice conceptual underlying pinning, so to understand variation in language and language processing. Okay, so let's have a look at dealing with this variation space or input variation. So some examples from research that we have been doing. Now back to AI or back to transformers. A challenge might be, how do we actually represent the input, right? If we represent language, that's one of the key questions. How do we actually represent it? And one of the key things is about tokenizing and tokenization of the input. And in language, that's very, very important. And I want to just show you example what happens if you have a sentence like here in German and the dialectal variant of it below. So this is a sentence about the Lammer has a quite clean water. It's a river. And what happens if you now tokenize this with a standard language model like here? You get these subtokens, right? And they somewhat approximate morphological boundaries, but they are not morphological, they're somewhat approximated. But if you now have a dialect sentence, what happens, right? Would it under-tokenize, over-tokenize? What would you expect? In fact, in this example here, we would see that it's actually over-tokenizing and getting many more subtokens for which the model then won't have good representations because it hasn't seen them. And so we were interested in how do we deal with this? What can we do about that? Okay. And my PhD student Verena was in fact interested in evaluating this non-standardness around on dialects. And so one way to, again, address and trying to find a way to address this problem, and one easy way to do so turned out to be noise injection. So if you randomly inject noise characters in your training data, in the standard training data, you're trying to bridge this gap from the standard to the non-standard, bringing it closer. And that helps essentially to get model performance up. So the darkish ones are the standard performance rates across diverse dialects. And yellow is what happens if you evaluate it in non-standard. And you see big performance gaps. But if you increase so this is the standard rate. But if you increase the number of noise injections, so a certain level of noise is actually helping to improve model performance to get this gap closer. So this is one way to do so. But of course, in order to evaluate this, you need benchmarks, right? So when we started in Munich to work on Bavarian dialects, in fact, there was not much around. There was, in fact, 0 data sets and benchmarks around. So in the last 2 years, we spent quite some time on devising dialectal German NLP benchmarks for Bavarian, or which include Bavarian variants, for slot and intent detection, for example, for named entities, for some more syntactic linguistic analysis, but also more recently for automatic speech transcription in multiple Bavarian variants together with the Bayerischer Rundfunk here. And we see overall that there's still a lot to be done to make these technologies work better on these variants. But when doing so, you might actually wonder, hey, what do dialect speakers actually want, right? And we were wondering, indeed, with my PhD student Verena, and we set out to do a survey in order to find out for these Germanic language varieties, what do they want? So if you have imagine you have a certain language technology, would it depend on whether this understands, your dialect, or should it also generate your dialect? And how does this, is there any correlation with social linguistic factors as well? So we did a big survey with over 300 participants, where we asked them to rate whether they would find these technologies useful or not. And what you see is there is a big tendency. So some technologies were not judged useful, like spell checkers, or here machine translation into dialectal variants. So translating the dialect was not so appreciated, but a lot of people thought about assistance. So talking to your phone, talking to your AI assistant in your dialect is very helpful. In fact, one finding here is, it was interesting that people really want to be understood, so that the dialect is understood by the system, but not so much generated by the system. Okay, think about it, makes also sense. All right. All right, so let's then move to the output space. I've shown you now a lot of what we are doing in the input space and trying to embrace language variation to make systems more inclusive. But what about the output side? Okay, and here I mean human label variation. Let me show you this picture. How many sticks do you see? Yeah, I heard different answers. Right. This is again an purposely ambiguous picture, soliciting different answers. And in fact, if we ask humans to judge something or label something, we often only ask them to give us one answer, right? But way too often, indeed we assume there is one right answer, one ground truth. But if we look and zoom out from this little picture here, we see that the world is much more diverse, much more ambiguous, much more grayscale than black and white. Okay, and so if we zoom out, there is a lot of diversity, ambiguity, different perspectives that might be helpful to embrace. Again, variation, right? So what can we do about it? Indeed, Laura gave a keynote at NeurIPS in 2023, and she had this nice example. Is there a smile in this image? Okay, how many of you would think there is a smile? Yes? A few? No? I don't know. A lot more, yes, exactly. So what she showed is they asked coders from different backgrounds, different countries, to give exactly this question, and they found striking differences in answer distributions. If you think about here, Canada versus the US versus India, for instance. So the key message here, it's really also your culture, your background might influence the annotation and the answer you give, or your state of mind. It's hard to say exactly what, but fact is, we observe different answers. Here, what about this question? What flavor is the dessert? Anyone? Yeah, I hear strawberry. In chocolate, exactly. Again, there's different answer possibilities here, or both together even sometimes, right? And also in language, if we think about natural language inference, that's the task of you have the sentence, like a context, a woman wearing a red hat and a black coat, and you need to infer a statement, a hypothesis. Is it entailed that a woman is asleep, given this context? If you asked a lot of humans, you might get, no, probably not. There is no entailment between these two sentences, right? If you then have another sentence like a woman holding a child in a purple shirt, the woman is asleep at home, then probably you might get, okay, some people see this perhaps more as a conflict here, where the woman is probably not asleep if she's holding the child and so on. So you see, again, different ways to interpret that sentence when we look at the labels there, and we look at what's called the human label distribution. If we have 100 people to give these judgments, we can look at these distributions to understand more about certain data points. And this is what I call human label variation, because this gives us, again, an important information about potential uncertainty in our data and in our models. Some people indeed call this disagreement. It's another thing that this is called. So disagreement or variation. And in 22, I wrote this paper to actually proposing to not call it only disagreement or annotator disagreement, but call it human label variation, because disagreement means it's exclusive, right? There is a disagreement, two things cannot hold at the same time, and has also this negative connotation. While we might have tasks which are very subjective, where multiple views can hold equally well, or in fact multiple answers might be true. So to embrace this richness of the literature on different terms, I propose to use it human label variation instead of disagreement. And that encapsulates all of these types of variation. But importantly, there is still what's called annotation errors. So some labels are errors and are not plausible. And the key is, how do we distinguish these two cases? Now back to our example. So what causes human label variation? For instance, if we had eye tracking, so if we could look at the cognitive process of people when answering this question for this image, what profession is the man on the right? Right? If I asked you that and we could now get access to your gaze, then I could perhaps correlate that with your answer, right? That you might say it's a priest or it's a drummer, depending on where you're looking at. So this is, again, contextual richness information that could be helpful. Or back to our example about the cake, right? How about what flavor is the dessert could also give us insights into the stimulus characteristics given rise to human label variation. So this is an increasingly interesting area that's being explored. But one question was what I often got, but you assume everything is plausible, right? And I just told you, no, that there is, in fact, also errors. There are errors that are made we know our data sets are containing errors. But the interesting question is, can we actually separate the two? Can we separate this, what's plausible variation versus what's error? And what we try to do is indeed try to come up with a procedure to do so, where we introduce reasons, we introduce explanations as insight in order to tease apart these two. So the key idea is to collect labels with explanations so that they gave us some more reasons of why a certain annotator is giving us a certain label. And let me show you an example. For instance, if we go back to NLI, here we have a premise. As he stepped across the threshold, Tommy brought the rickshaw down with terrific force on his head. Would that entail or contradict or be neutral to Tommy hurt his head bringing the rickshaw down? Right? And probably a lot of you would probably answer now, there is an entailment relation between the two, right? But if you look at this data set, chaos NLI, which has 100 annotation, we see there is a proportion of neutral and some contradictory statements. So are these errors or are they plausible? Right? And what we did here is essentially re-annotate this with what we call ecological, or what Young et al. Called ecologically valid explanations, where we ask the same person who gives the label also the explanation. So they are not decoupled. And this way we can find, for instance, entailment because Tommy's head was hit with force, but maybe also neutral because it's actually ambiguous if Tommy hurt himself or it's another person. Okay, so there's an ambiguity, a pronoun ambiguity in the example that might give rise to this other reading. Or contradictory, but then we got a bad explanation. So we collect this and then ask annotators back, is this label explanation plausible, in order to find out that, actually contradiction is an error, while the other two labels are plausible variations. And so we tried this and tried to then tease those apart. But in fact, the most important bit here is that we proposed this two-step procedure to tease apart error from noise that could be also moved forward to other tasks and could be interesting to look at for other tasks. Now, this is all about labels, and we now talk about generative AI. But human label variation is essentially also important for generative systems. And we were interested in looking at this from different perspectives. For instance, back to LLM as judges, can we use an LLM to approximate human judgment distributions? Okay, so you see, in our research, we often have this human versus machine question. Can we approximate one with another? Or how similar or how different are they? And here's this is collected by humans, and we want to see, can we solicit the same with LLMs? And so can we actually use a few explanations, so labels with explanations from before, in order to approximate this distribution from the humans? And would using explanations as input, as additional source of information, help us to do this better? That was the question in this study. And what we found is actually interesting, that here you see the distribution of the instances over these 3 labels from the human side, and here are 2 distributions from the language model side, Llama and Mixtral. And what you see is it looks like Mixtral would be closer to the human distribution, but what it turns out is that if you zoom in, then this distribution is actually closer. Oh, sorry, I don't have much results, but there's interesting, different language models capture variation to different degrees, but the important thing is we could approximate this distribution quite well and could also use that as a proxy to train then models on this. So this is very interesting and very promising technique with some interesting insights in the details of this methodology. But what about text generators? Now I talked a lot about labels, right? Discrete classes, but often we just ask LLMs to generate outputs, right? And the same question holds. If we ask a human, for instance, to do translation, right, then we might get very diverse answers. And indeed, here you have an English sentence translated by different human translators into these different targets. So here reacted cautiously was translated in different ways. And we were interested in how close would LLM outputs be to this richness of human references, right? These are human reference translations. And what we found is, again, they are overly narrow, overly confident in generating only one certain form out of this richness. And we tried to, essentially the idea was, can we get human data sets where we have multiple human responses? And again, how do they compare to LLM outputs? And so in a nutshell, what we found is essentially there is still a long way to go. So if we look at different, say, aspects of variation, so let's say lexical, syntactic, or semantic variability, we try to measure how close are these outputs by machines versus outputs by humans along these three scales. If we are here at 0, essentially they would be very similar. And what we see is in diverse tasks, so we have machine translation, simplification, and dialogue, we see language models react differently for different tasks. So for machine translation that we just saw, they were actually underestimating the human diversity. So they were not as diverse in the outputs as you would expect from a human translator. On the other side, if we look at dialogue, in this data set we had multiple continuations in a dialogue, we saw that they were actually overly generating. They were overly chatty. They were not answering as you would expect a human to answer in that situation. So again, this means they are not well calibrated yet to how we would, as humans, communicate and these expectations that come in communication. So do text generators reproduce human production variability? They over or underestimate this depending on the task, and there's a lot of interesting direction here directions to look into. And these were now 3 tasks. We were now recently interested in also summarization, right? That's another task. If I give you now the task to summarize a document, and I would ask 5 of you, then probably I would get 5 very diverse summaries, right? There are some data sets around that have, again, multiple references, so like SumEval. And what I show you here is this, again, richness of variation in human summaries as measured with Rouge, which is a very simple but very common way to measure overlaps between summaries. And what I want to show you here is that, again, human outputs are very diverse, summaries are very diverse, and each line is one document, and the summaries for the document and the pairwise similarity between the human references. Okay, so if we then, so there are around here 25 to 30 Rouge, right, on average. If we summarize that and we get this distribution here, But what we were interested again is how do these human references compare to model-produced summaries, sorry, not references. And what we see again is that they tend to be much closer to themselves. So LLM outputs are closer in style than human references, less varied. Models. And if we zoom in into only LLMs, so these are also including more traditional summarization methods, not just LLMs, then that gets even more narrow. So LLMs by themselves are closer to each other, not encapsulating this rich variation of human outputs. So yeah, exactly. They exhibit less variability. So this all is kind of, related to this concept of human level variation from a generation perspective, that we don't, there's a lot more to be captured. And there is a lot more growing interest in human level variation from all sorts of perspectives, from more subjective tasks and so on. So it's really nice to actually see that the community is really looking at this now more and more. In fact, if some of you have been at ACL this year, there was a very nice keynote by Verena Rieser, who is working on pluralistic alignment. So how do you post-train systems in order to align better to human values? And this might have connections to the talk you saw yesterday, indeed. And so again, how do we do alignment for better AI in future? And Verena was interestingly, in fact, nicely pointing out to our few former talks. So Laura, that I mentioned before, and my recent talk at ACL 24. So overall, we need to incorporate much more diversity in AI broadly. All right, and why that? Because that helps us to get more trustworthy AI in future. So if you think back at this pipeline, the human matters everywhere, right? It's not just the data. It's the decisions that go into the modeling. It's the decisions that go into evaluation. It matters everywhere. That's why it's important to have the human dimension in all of the AI pipeline, in order to also increase trustworthiness with users that then use this technology. And back to my quote, I think if we really work together as a field or as multiple fields to increase knowledge of origin and knowledge of functional capacity, then we will get this knowledge, and that's also essential for increasing user trust. And that can be along many dimensions. So we wrote up some desiderata for trustworthiness in LLMs, because if we have better knowledge about what goes into the models, knowledge about model input, knowledge about the origin of the data, knowledge about the behavior of models, how do they react in certain circumstances, in certain contexts, what are they good at, what are they not good at, or knowledge about better evaluation protocols. So evaluation is really an open problem that will keep us busy for a long while. Then we can get more trust, more knowledge, and more trust into. Why? Because LLMs are really exciting to have. They will stay, and they are indeed part already now of an LLM ecosystem, right? Where we use them in all sorts of ways with other modules. And in fact, Mirella Lapata has mentioned it as this LLM ecosystem in her keynote in 2024. They will be essential part of this ecosystem. Or Dan Roth has mentioned it, similar arguments, but more focusing on the modularity aspect, that there is this modularity and LLMs will be the new UX, essentially. And it's a beautiful visualization, but I do think that there are some missing ingredients in this picture. If you look at it, what's missing? Well, it says nothing about the input, right? It says nothing about the output. And I think there's very interesting other areas to look at and learn from the linguistic side or social linguistics, but also about survey scientists and opinion mining researchers, how to actually collect data in representative ways. Also looking at the output side, label variation that I have shown you so far, but also again the social sciences for whom we are developed in the systems, or the whole human-computer interaction perspective that is very important as well. So all in all, and in addition, this is now represented as this black box, but there is interesting work in interpretability and opening this black box to understand mechanistic interpretability or interpretability research, to understand what's going on under the hood, to find actionable insights. But all in all, I think the human aspect is very central here and missing, because we do have language variation and human label variation, and that's essential to essentially close this gap and have a really what I would call trust LLM ecosystem for trustworthy future NLP. So to wrap up, I have shown you in this talk LLMs and challenges with LLMs. I hope I didn't scare you too much, more like gave you some pointers of thought. And now it's really exciting times. It's time to regain trust and look at all of these diverse aspects. We need to, I think, to embrace variation more holistically, think about inputs, outputs, but also as, take language as a bridge and LLMs as a bridge to many other research communities. I think now it's really increasingly been done in other fields in order to build this trust LLM ecosystem together. And with that, I thank you for your attention. I would like to thank my team here, but also you for inviting me. And if you're interested in some of these aspects, I can point you to 2 or actually 3 upcoming workshops that are relevant at Colm and at EMNLP. And thanks a lot, and I look forward to your questions now.
Not necessary. We do not have too much time. I know that we have to allow difficulty to re-switch the computer. So, okay, thank you. I think that I'm quite have a. Maybe not. Okay, thank you very much. Exciting talk. And, we didn't plan it, but in some way you make a connections toward the Sunday opening conversation, let's say, about data input and output, and also yesterday keynote about human is important. So it's fantastic.
Thank you.
2 questions, max, or comments, but not very long, Marcin. Okay.
Thank you for the talk. Very interesting for me, especially working with any NLP task. I think linguistic work and tagging data and preparing this data it's super overwhelming, and it's super complex and long-lasting process. And we know this always not enough data to train. I wonder 2 things from the talk. One thing was this criticism about the simple answers when we can evaluate with this answer. This is of course convenient, because it's easy to compare, it's easy to evaluate, and the other way, very hard. I don't know if you have any other options how to fair way compare to different models.
Right. Do you mean the logic-based extraction, right? That
yes.
part. Yeah. No, the what I want to point out is not so much to criticize, it's more to raise awareness that there might be these biases that you slip into if you just do one evaluation. So it depends on what you're measuring, right? If you are only interested in getting some performance estimate, and then at least permuting the answer options and doing that is already, good enough. But if you then go and do statistical analysis and try to do some inference on some populations and so on, then I would argue perhaps compare to another type of extraction. So that's more the point, to think about, okay, is my extraction reliable for what I'm interested in, and take that into consideration. So very good question that for when. There is no gold answer for when to do what, but more think about, there is so much choice, and the impact is seemingly small choices which are sometimes convenient and fine, but sometimes they might actually give you some overestimates that might be mattering way more to go back to think about these details. Yeah. Thanks so much.
Thank you.
Yeah.
Okay, so in one of your slides, there was something like 7,000 languages. And I'm starting to think, because on one hand side, we can try to cram 7,000 languages into ChatGPT 25.0 and try to improve its performance. On the other hand, we could try to develop 7,000 mini chats and make sure that each one of them has a very precise and very detailed understanding of its own local language. So there will be 3 or 4 chats for Bavaria, let's say, and each one of them will be perfect for a different dialect. And then there is probably a lot of stages in between, and I would like your reflection. Mm-hmm. If one is everything in one,
right,
the other one is 7,000 different ones. Right. Which way should we go, really?
Yes, that's a great question, because it's a question of decisions and balances, and there was this time where back also multi-tree generation, right? Cramming everything into one model was the solution, and having one for everything, right? Scaling up, building into. But then there is this what's called the curse of multilinguality, that we know that there is only so much capacity that you can put in. So nowadays language models the original had 100, and scaling up to 500 was possible. Now 1,000, 2,000, we're reaching the max, right? But what's more is the alternative would be, in fact, as you mentioned, the monolingual models that are very tailored to one single language itself. But I think we need to think of this as like discipline distribution, where there is a nice balance somewhere in neither on the extremes. The question is, where on this continuum do we want to be? And that's the question, and that's the kind of the glory, holy grail, essentially, if we would have a solution for every new language variety. But we need to think of taking what can we use to make more informed judgments on what could be? Because we know sharing between languages is beneficial, right? Why would we not share? But to what degree should we share to not have interference? And then knowing that, and there has been more work on that originally, but less nowadays, to kind of have more informed decisions on what could be beneficial sharing will be interesting, to kind of know where to put your money on this continuum. I believe it's not just monolingual models, but some degree of sharing should be there, personally. But then how do you decide? That's the question. And that's an interesting question. And then again, talking to typologists who might help, but it's also an empirical question often. So a lot of considerations go into there, and it's a very interesting question. And no, I would not go to single model all the way to the extremes, but somewhere in the middle.
Yeah, I remember this feeling of ocean in front of you on the first meeting of multi-street generation. Oh, what to do with it? Yeah. Okay, so sorry, Barbara will stay with us till tomorrow. I hope you will with us during the banquet.
Yes, also. I will be there.
So if you have, I think that you have question, or you would like to talk about something, some ideas and so on with Barbara, so you can do it. Right now I have to clean this scene for the another speaker, and I would like to invite the next chair.